Have you ever asked yourself, how are we able to see and how are we able to hear? Well, to answer that question, we need to answer another question, which is, what the heck are waves? So, in today's episode, we're going to find out.
APT science time. APT science time. APT science time.
Inertia is a property of matter. APT.
APT science time. APT science time.
So, what a wave is, it's a disturbance in the atmosphere. There's a disturbance in the force. No, not that disturbance. Actually, what a wave is a disturbance in the atmosphere that carries energy from one place to another without actually moving any particles around. Now, you may be asking yourself, what are the 3 factors to every wave? I don't know, future me. What are they? I don't know. It's not on the script. Well, you should know. You made this video. Yikes, that guy's got an attitude. A wave's 3 factors consist of amplitude, frequency, and wavelength. Now, to show amplitude first, the simplest one, we're going to have to head down to the pool. Hey, Mr. APT. How'd you get? Before we go to the pools, I just want to demonstrate amplitude by myself. Okay. Got it. Yeah, see? I'm a smarty pants. And just like you're a smarty pants, I can also explain scientific stuff. So here's how it works, okay, viewers? You're right there. You on the right? You pay attention? Alright. So here's what a wave looks like with low amplitude. You go. And this is what a wave of high amplitude looks like. See? You're not the only smarter one here. I'm smart too. Don't you agree with me, viewer on the left? Address the viewers. There's probably only one watching this. You mean I'm not supposed to address them? We're standing right there. Oh. Well, anyways, that's not amplitude, that's frequency. We can show it better at the pool. But, of course, you can explain it better by yourself. Alright, let me show you how amplitude works. I'm going to drop this golf ball in the pool. Wasn't that big of a splash, right? Well, how about if I drop something bigger? Like this bowling ball right here. Let's see. The next 2, wavelength and frequency, they're basically connected. What a wavelength is, it's the distance between 2 crests in a wave. Remember how I said it was repeating? Yeah, that's what a wavelength is. They measure the distance between those. And the frequency is basically, it's in the name, frequent. It's how frequent the waves appear. So, a wave like this would be high frequency because the waves are close together. But the wave like this would be low frequency. But as you can see, the lower the frequency, also the higher the wavelength. This is why they're connected. They have what's called an inverse relationship, which means when the frequency increases, the wavelength decreases. Now there are 2 main types of waves. There's mechanical waves, sound mostly. Then there's electromagnetic waves, light mostly. We're going to be covering mechanical first. Let's go. So, each of the 2 types of waves that I mentioned, they both use amplitude and frequency in different ways. Let's start with sound waves. The amplitude, how it works in a sound wave, is that the higher the amplitude goes, the louder the sound. Nice. And so I'm going to turn that down. And frequency is what determines the pitch of the sound. So a higher frequency means a higher pitch. At a certain point, our ears are unable to hear a highest pitch. Now with light, it's different. The amplitude in light waves controls their brightness and how bright they are, which makes sense. The frequency of the light waves, however, is completely different. The spectrum consists all the way over here with radio waves that goes from radio waves to microwaves to infrared to visible light, the light that we can see, to ultraviolet, to X-rays, and to gamma rays. These go from lowest to highest frequency, and the visible light, the frequency of the light, determines the color. If it's a lower frequency, it'll be more red, middle frequency is more green or yellow, and the highest frequency is more purple. That's why past is called ultraviolet, and before it's called infrared. Get it? Makes sense to me. Video is over. I just wanted to say that I really appreciate you guys for sticking out for this video to the end. Unless you're Miss Olmstead watching this, which, hello. Anyways, what we learned that the wave is a disturbance in the atmosphere. There are 3 different ways that a wave could travel, 3 different factors to a wave, 3 different parts to a wave, and 2 different main types of waves. I think we got all that covered, so